In the lower portion of your notes, you reserved a space. I'd like you to write in the theorem that we're about to go over and a proof on the next slide in that section. This is theorem 2-3, and it says vertical angles are congruent. And please remember, oh my gosh, I do not want you to memorize that it's 2-3. I want you to remember the meat and potatoes of the theorem, what it really says, and that's why we gave them AKAs. So we're going to call this theorem also known as the vertical angle theorem. Vertical angle theorem. And I'm just going to abbreviate theorem to THM. So that'll be our AKA. Now, even though this theorem is super short, it's probably one of the most popular theorems. We're going to be using this quite a bit, and it really says something pretty simple. Suppose you have two intersecting lines. Here's my two intersecting lines. The first thing that a lot of students have a difficult time doing is just identifying the vertical angles. Now, vertical angles, suppose here's an angle here, made by this space right here. The angle that's vertical to that angle is the one that touches it on this side. The noses, the vertices of the angles touch. So you could say that angle 1 and angle 2 are vertical angles. Therefore, angle 1, the measure of angle 1, is equal to the measure of angle 2. Or the same statement would be angle 1 is congruent to angle 2. And that's all that theorem says. Now we're going to go over a proof of that vertical angle theorem. What I've done here is I've given you the given and the proof and this diagram. And I've given you the two-column proof here, but I've cut out the reasons portion. What I'd like you to do is pause the video in a second, and I'd like you to try to look at the statements, follow their logic, and see if you can write in the justification yourself. I'll use a pencil and be prepared. After you unpause the video, you'll see how you did. So go ahead and pause the video, and let's see how you do. Okay. So I'm going to go ahead and move Luigi out of the way. Maybe I'll put him up here climbing that angle. Oh, he's running off the side of the screen. Okay, the first thing I want to point out is your textbook made a huge error. It forgot the given statement, so I added that in. So angle 1 and angle 2 are vertical angles, and that was given. Now, our second part in the logic says the measure of angle 1 plus the measure of angle 3 equals 180. Angle 1 plus angle 3 equals the full angle, which is a straight angle, happens to be 180 degrees. It also says angle 2 plus angle 3 is also 180 degrees. That's angles being added together to equal the bigger angle. That's the angle addition postulate. How are you doing so far? Did you get that part? I bet you did. Okay, here's the tricky one. The measure of angle 1 plus the measure of angle 3 is equal to the measure of angle 2 plus the measure of angle 3. It's a little tricky, but see if you can follow me here. In the previous step, we said that the sum of these angles is 180 and the sum of these angles is 180. They equal the same amount. If they equal the same amount, then I can say that these two angles are equal to these two angles by, did you say substitution? That's right. We substituted this section right here, these two, for 180. That's how this jumped over here. Next, for step 3, they said the measure of angle 3 is equal to the measure of angle 3. Something is equal to itself. That's the reflexive property. Reflexive property. The reflexive property. And last but not least, you can see that they've removed the measure of angle 3 from this equation to leave the measure of angle 1 equals the measure of angle 2, or angle 1 is congruent to angle 2. It's like they subtracted it, but not just from one side, from both sides. Well, that's pretty obvious. That was the subtraction property of, this is key, if you don't have this, it's wrong. It's a subtraction property of equality. I'm sure you did very well in that proof, and this is great practice for the future when you're going to have to be writing in not only the justifications but also the statements.